In this lesson, we're going to look a little closer between the relationship of scale factor and perimeter and scale factor and area. So using figure A below, so looking at this rectangle, I'm noticing that this rectangle has the dimensions of 4 by 1, 2, 3, 4, 5, 6, 7, 8. So it's 4 by 8. So another rectangle that could be similar to that would be, it could divide both of these dimensions by 2 and get 2 by 4, or 1 by 2, or 5 by 10. So anyway, draw a rectangle that has a scale factor of 1.5 of rectangle A. So what that means is I'm going to take this dimension, 4 by 8, and multiply the 4 by 1.5 and multiply the 8 by 1.5. So to multiply something by 1.5, you take the number and add half of it. So 4 plus half of 4 is 6, and 8 plus half of 8 is 12. So I'm going to make a 6 by 12. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it should look similar. So this is 6, this is 12. I think I did that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops, I need to make it go a little bit farther to the right. So the area of the original rectangle is 32 units squared. The area of the new rectangle, 6 times 12 is 72 units squared. The perimeter of the original one, well, it's 4 by 8, so 4 plus 4 plus 8 plus 8 is going to be 24. And the perimeter of the new rectangle, 6 plus 6 plus 12 plus 12 is 36. So if I'm looking at the relationship between the area and the new area, it's going to be 32 times the scale factor, which is 1.5 squared. So if you do 32 times 1.5 squared, and I'm getting my calculator out and doing it. So 32 times 1.5 times 1.5 is 72. So that works. Now to find the perimeter, I'm going to take the perimeter, which is 24, and just multiply it by the scale factor, which is 1.5, and I get 36. So if you take the area of the original one and multiply it by the scale factor squared, you're going to get the new area. If you take the perimeter and multiply it by just the scale factor, you get the new perimeter. Now I'm going to draw a rectangle with a scale factor that's half of the original one. So the original one was 4 by 8. So let's make a 2 by 4. So the original area was 4 by 8. That's 32. The new area is 2 by 4, which is 8. The perimeter of the original one is still 24. And the new perimeter is 4 plus 4 plus 2 plus 2, which is 12. So remember, our scale factor is a half. So let's look to see if this made sense. So our original area is 32, and we're going to multiply it by the scale factor squared. So 1/2 times 1/2. And when I do that, I'll get 1/2 times 1/2 is 1/4. So 32 over 1 times 1/4 is the same thing as 32 divided by 4, which is 8. So that works. Now let's check out the perimeter. So the perimeter, I take the original perimeter and just multiply it by the scale factor. which is 1/2, and I should get the new perimeter, which I did, was 12. So if we can formalize this, what is the relationship between the scale factor and the perimeter? So what you need to do is take the original perimeter and multiply it by the scale factor to get the new perimeter. What's the relationship between the scale factor and the areas? So what you do is you take the original area and you multiply it by the scale factor squared to get the new area. So if you square a number, remember with exponents, if you have scale factor squared, that's just multiplying it by the scale factor twice. So let's fill in this chart here. So if we're here, if I know that the side length of A is 1 and the side length of B is 3, and these two figures are similar, my scale factor is going to be, from A to B, is going to be B divided by A, which is 3. So the perimeter relationship is going to be the same thing as the scale factor. So it's going to be times 3. The area relationship from A to B is going to be times 3 squared. That's going to be our pattern. So if I have a side length of 2 and a side length of 4, and I need the scale factor of A to B, I'm going to do B divided by A, which is 2. So my relationship is from A to B for perimeter is going to be times 2. And my area relationship is going to be times 2 squared. I'm going to start making these as numbers. So this is times 9 and this is times 4. So if I have 3 to 6, 6 to 3, 3 divided by 6 is 1/2. So my perimeter factor is going to be times 1/2. And my area relationship is going to be 1/2 squared, which is 1/2 times 1/2, which is 1/4. Next line, 7/5. So 7 divided by 5. That's just an improper fraction. I can leave it like that. So my perimeter factor is going to be times 7/5. And my area is going to be times 7/5 squared. So I'll write it up here. So 7/5 times 7/5 is going to be 49 over 25. So this is 49 over 25. Okay, next one, 9 divided by 6. Well, 9 divided by 6 reduces to 3 over 2. So the perimeter relationship is multiply it by 3 over 2. And this one's going to be times 3 over 2 squared. So 3 over 2 times 3 over 2 is going to be 9 over 4. So I'm going to multiply the area by 9 over 4. Okay, the next line, the scale factor is just 5. So I don't know what the original A and B are, but I know that if I divide B divided by A, I'll get 5. So I'm just going to keep it simple and use 5 and 1, but there can be more than one answer. So my perimeter relationship is times 5, and my area relationship is times 5 times 5, so times 25. So perimeter relationship is 6 times as long, so times 6. So my scale factor is 6. So I'm going from 1 to 6. And again, there can be multiple answers in here. Any number that when you take B and divide it by A, you get 6. So my area is going to be times 6 squared, which is 36. Okay, these bottom two are a little trickier. So if A has an area that's 9 times as large. So A is the bigger number than B because A is 9 times as large. So this means, actually, if A is 9 times as large than B, so this is going to, the area relationship between from A to B is 1/9. I'm going to write it like that. So if A is 1/9, if I take 1/9 of A, I'm going to get B. So that means that the perimeter is going to be, what number do I multiply it by itself twice to get 1/9? Well, that has to be 1/3. So this has to be 1/3. And so this one is going to be 3, and this is going to be, actually, I did that the other way around. This one should be 3. And this one should be 1 because 1 divided by 3 is 1/3. Okay, and the last one, A has an area that's 16 times as large. So this was times 16. But if the relationship is from A to B, then it actually has to be 1/16, just how we did the other one. So if this is 1/16, this one has to be 1/4 because 1/4 times 1/4 is 1/16. So the scale factor is 1/4. This one is 1 and this is 4. So this part was confusing because it was written a little bit differently. It wasn't written from A to B, it gave you A first. Okay, sketch a similar rectangle to the one below that has an area of 1/4 of the area. So remember, if our area factor is 1/4, then that means I can find the scale factor by taking, what number do I multiply by itself twice to get 1/4? So that means the scale factor has to be 1/2. So I'm going to take 1/2 of each of these sides. So this was a 3/5. So now I'm going to make it into 1.5 by 2.5. So 1.5 by 2.5. And actually you can kind of see visually that you're cutting this rectangle into fourths. There. So that's better. So cutting this into fourths, because it's 1/4, will give you a 1.5 by 2.5. Last one, sketch a similar triangle that has an area that is 4 times the area of this rectangle. So if we're in order for it to be 4 times, the scale factor is going to be times 4. So remember, what number do you multiply by itself twice to get 4 is 2. So scale factor is 2. So I'm going to double the length, or the base, to be 4. And then noticing right here that it's going up 2, right 1, I'm going to go up 4, right 2. So I'm going up 4, right 2, and then the same way over here, up 4, right 2. So this is my new triangle.